Hi everyone. So far we saw the general rule for the discrete and continuous random variable, and specifically this video is for the common discrete distribution. So as I said, so far we saw the general rule, but in fact in real life we see the same scenarios repeating over and over. Those scenarios take on a special form. In this video we'll see the famous or the common discrete distribution, including Bernoulli binomial distribution. We have Bernoulli, we have binomial distribution, we have other distributions that we see in other videos. We have geometric, hypergeometric, Poisson, and discrete uniform, which is because why we call it discrete uniform, because you have continuous uniform as well. So let's focus in this video on Bernoulli and binomial distribution. So what is Bernoulli distribution? So the Bernoulli experiment is a single trial with only two outcomes. So I have, for example, when I flip a coin, either I get a head or a tail. I don't have other outcomes. For example, for let's say the absence, either the student come to the lecture or will not come. Either it will rain or no. So I have only two outcomes. For example, tossing a dice, we get values from 0 to 6, from 1 to 6. So this is not a Bernoulli experiment, but if my if my random variable is getting an odd number, so here it becomes Bernoulli, because either I get an odd number or I get an even number. I have only two outcomes. So this is actually the Bernoulli random variable. So it can get only two values, two outcomes, and we call one the success and its probability is P, and 0 is the failure with probability 1 minus P, because I have only yes or no, or success or failure. So I have P and the rest is Q, and Q is 1 minus P. Let's see an example here. So if I flip a coin, this is our table. If I flip a coin, my result can be head or tail. So if my x is the random variable that count the number of head, so h here, the number of head, can be either 0 or 1. That's the only outcome I can have. So what is the probability to get a head? It is P. We call it P. This is the probability of success, getting one head. And the probability of not getting a head is the same as probability of getting a tail, which is 1 minus P. So this is the probability of failure. And now if I want to find the probability or the expected value, we do the same thing as the general rule says. So this times this, I get 1 minus P, plus this times this, which is P. So 1 minus P plus P, so 0 times 1 minus P is 0, and 1 times P is P, and the total is P. That's the expected value. What about the variance? We know that the variance is ex squared minus ex squared. So what is this? So it's, we square this value and we multiply it by the probability, we get 0. We square this value, multiply it by this, we get P. So in the end we get P. This is P, and minus, we know that x is p, so p squared. P minus p squared is actually p 1 minus p, and 1 minus p is q, so p times q is our variance. So for the Bernoulli distribution, it is always true that ex is always p and vx is always p times q, or p times 1 minus p. So this is a general rule for Bernoulli distribution. And for the probability mass function, which is p x equal x, it is always p if x is 1, and it is q or 1 minus p when x is 0. So the probability that we get 1 hat is p. The probability that to get 0 hat is q, which is 1 minus p. So this is how it works with Bernoulli. We saw this because we need it for the binomial. So now let's see what is the binomial distribution. Okay, before this, let's see this small example for the Bernoulli. Now imagine we flip an unbalanced coin. We have the head, we x count the number of head. So head is success, tail is the failure. If I know that the p, since here it's unbalanced, so the p is different from q. If p is 0.6, if p is 0.6, q is 1 minus 0.6, so it is 0.4. How to find the expected value? So we said expected value is same as p, so it is 0.6. And what about vx? Vx we said is actually p times q, which is 0.6 times 0.4, we get 0.24. Now if I apply our general rule we saw in the beginning with the discrete random variable by using this table, how to find x? We said the expected value is the sum of pe times x, so 0 times 0.4 is 0, 1 times 0.6 is 0.6, we get 0.6. For the variance, we know it's the e of x squared, and how we got this, so we square 0 times this, 0, we square 1 times this, it's also 0.6, and here we got the e of x squared minus x squared. We know that x squared is 0.6 squared, we get 0.24. So from now on, when you know that this is a Bernoulli, no need to use a table, etc. Just use to find ex, the expected value, just say it is p. To find the variance, no need also to make this calculation, just to say it is p times q. Now let's see how to work the binomial distribution. So now that you know what is the Bernoulli distribution, the binomial is simply Bernoulli but repeated n times. It is repeated n times, and the notation for binomial is this. So x follows the binomial distribution with two parameters. What are those parameters? N is the number of trial, and p is the probability of success. So for example, if I flip a coin once, this is Bernoulli. If I flip it twice, it becomes binomial. Okay, for Bernoulli the notation is here. So x Bernoulli p, it has one parameter because n is 1, there is no repetition. But for the binomial, we write it like this. So x is a binomial distribution with two parameters, and is the number of trials, the number of experiment, and p of repetition, sorry, and p here is the probability of success. Now let's see an example. Here, imagine I have this experiment. I flip a coin 3 times. My question is, what is the probability to get one head? Now we can write this in the notation of my random variable. So x follows a binomial distribution with 3 trial and p probability of success is 0.5. So let's find this probability of getting one head. That means we want to find this px equals 1. What is actually, I have 3 trials and I want to get the probability that I got one head. The probability of one head is p. That means the 2 other trial I must get a tail. So if this is the probability of the head times q times q, because I get a tail, I will get only one head. So this is the probability of getting one head. This is the probability of getting a tail. This is the probability of getting a tail. So this is how I write it. Now what is here, actually if x is the number of success, I mean here if I said I want one head, so I can write this like this. It's p power x. Why here? Because if I want 2, the probability of x equals 2, which means I will get 2 head. Okay, if I want this, the probability to get 2 head, so it is p times q, so it becomes p squared here. So let's write it like this, p power x times q. So the number of failure automatically will be the number of trial minus the number of success. So it is n minus x. For our example here, we said the number of head is 1, the number of success is 1. So it is p power 1 times the number of failure will be 3 minus 2, which is 2, so it is q power 2. But if I say what is the probability of x equals 2, here we have 2 success, so it is p power 2 times how many failures? Since I have 3 trials, 2 are success, the remaining one is q power 1. 1 is x minus n minus x, which means I have 1 failure. So if I sum up this with this, I get n. So if I want, for example, px equals 3, that means p power 3 q power 0, and so on. Okay, so this is for the first step. But also I know that I can get this in different ways. I can get one head in different ways. What are those ways? So it can be p times q, but also it can be q times p times q, or maybe q times p. I have different ways to get this. So the probability actually is the sum, either this or this or this. So we sum up all of this. So now how to find the number of ways I can get it? Actually it's the combination of getting one head among 3 trial. So it is a combination. Simply it says, this one says that it equals 3. That means I have 3 different ways to get one head among 3 trial. So the final formula for the binomial distribution actually is this part but we need to multiply it by the number of ways to get it. The number of ways is simply the combination of getting x from n. So this is our final formula to find the probability of x equals a specific number, which is actually the PMF, the probability mass function. So in binomial, when you have a binomial distribution and I want to ask you, for example, what is the probability of x to get specific value, you can use directly this formula, which is the combination of x from n, the number of ways we can get one or two, whatever, head from n trail, okay, and we multiply it by the probability of getting head. In this example, power x, the number of head here, times q power the remaining, which is the number of failure, n minus x. So this is the formula. Let's solve an exercise to make it even clearer. So here in this exercise, which is the same example here, so we have the this experiment. We flip a balanced coin 3 times, and my question here is not getting one head but getting 2 head. So what is the probability of getting 2 head? It is simply the combination to get 2 among 3 times probability. We know that it is balanced, which means it is 0.5, power the number of head here, the same thing, so power 2 times the probability of not getting a head, which is 0.5, power the number of failure. Here the number of failure is 3 trail minus 2 head, and we get 1. We replace, we get 0.0375. So this is how you find the PMF, the probability mass function, when we have a binomial distribution. For the to finish this video, for the expected value, it is simply as the Bernoulli. We said Bernoulli, it is P, and since the binomial is Bernoulli n times, so the x here is n times p. N times p. Here p is 0.5, n trial we have 3, so the expected value is 1.5. For the variance, Vx is n. We know for the Bernoulli Vx is p times q, and since Bernoulli is binomial is Bernoulli n times, so we multiply it by n. By n we get n times p times q, which is 0.75, which is actually 3 times 0.5 also times 0.5 for q, we get 0.75. And if we want to calculate the Vx using the general rule with this table, we get the same result actually, so it is 0.775. From now on, when you know that it is binomial, so you can use this table only for this. Use the formula here, use this formula, this one, to find the PMF. You can write down all the results here, and the total will be 1. For Ex and Vx, you don't need this anymore. You just apply n times p times q. And for the CDF, which is the cumulative distribution function, you can also add a row here for CDF, okay, which is fx using this. For example, here fx here for f0 is 0.125, For f1 it is this plus this, and for f2 it is the result here plus this, and so on. So this is all about the binomial. In the next video we'll see the Poisson distribution. Thank you for watching.